morning, friends. Now we are going to discuss about the heat engine. What is the heat engine and what is the block diagram of heat engine or how it works, and what is the efficiency of a heat engine. Right. Now the question is that explain the heat engine and its working. What is the construction and working of a heat engine? At present, in our day-to-day life, we are using the heat engine in our vehicle, right? So how it works? So the basic concept about the heat engine we are going to discuss on that. Actually, the heat engine is work on the base of the cyclic process, and for the cyclic process we obtain that the Q is equal to W from first law of thermodynamics. Okay. Now, what is the heat engine? Heat engine is a device by which a system is made to undergo a cyclic process that results in conversion of heat to work. So, heat engine is the device in which a system undergoes a cyclic process, and as a result it converts the heat energy into the work. Right? Again, what is the heat engine? Heat engine is a device in which a working substance of the system undergoes a series of thermodynamic process and returns back to its initial state. That means undergoes a cyclic process. That results the heat energy is converted into the work. So the principle of the heat energy is that principle of the heat engine is that to convert the heat energy into the work or the work energy. Heat energy is converted into the work. That is the principle of the heat engine. Again, the heat engine is a device in which a working substance undergoes a cyclic process that results the heat energy converted into the work. So that is the basic concept of the heat engine. Now, a simple heat engine is shown in the figure. The gas enclosed in a cylinder with a piston. Here the gas is taken as a working substance that is filled in a piston cylinder as well. Right? This working substance or this gas receives the heat from a burner. On absorbing the heat energy, the gas is expanded and piston pushes up. So we'll start rotating. So how this heat engine is work? So in a simple heat engine is shown in the figure. The gas enclosed in a cylinder with a piston. This gas receives the heat from the burner. So absorbing the heat, the gas is expanded and pushes the piston upwards, so that the wheel connected with the piston start rotating. Right? Here we are going to discuss about the working of a heat engine. The heat engine is shown in the figure. A gas is filled in a cylinder with a piston. This gas receives the heat from the burner. As a result, gas expands and pushes the piston up. Pushes the piston upwards. So wheel start rotating. To continue the rotation of the wheel, an arrangement is necessary to the heat engine so that the piston can move up and down periodically. So due to the expansion of the gas, the piston pushes up. So the wheel starts rotating. To keep the rotation of the wheel continue, so the arrangement is necessary in which the piston can move up and down periodically. So as a result, the wheel connected with the piston is continuous rotating. Continuous rotating. So this type of the arrangement is required. Here, whatever the gas filled in a piston cylinder arrangement, that is known as the working system, working substance. And the burner is known as the heat source. that is known as heat source from which the gas absorbs the heat. Again, what is the heat engine? The heat engine is a device in which a system undergoes a cyclic process. As a result, the heat energy converted into the work. A simple heat engine is shown in the figure. Right? A gas enclosed in a cylinder with a piston that receives the heat from the burner, and gas expands and pushes the piston up. The wheel connected with the piston starts rotating. As the piston moves up, the wheel starts rotating. To continue the rotation of the wheel, an adjustment is necessary to the heat engine so that the piston moves up and down periodically. So as the piston moves up and down periodically, so what's happened? The rotation of the wheel is continued. Okay. The gas filled in a piston cylinder arrangement, that is known as the working substance, right? The gas absorbs the heat from the burner. So burner is known as the heat source. The heat engine are two types: external combustion engine, such as the steam engine, and internal combustion engine, such as the diesel, petrol, and gas engine. In our daily life, we are using this type of the engine. In railway, at present, we are using the electric engine. But in past, before the 5 or 10 years ago, the steam engine are used in railway. So in steam engine, the fire takes place outside the piston cylinder arrangement. Here, the fire takes place outside the piston cylinder arrangement. So that is the external combustion engine. Because the fire takes place outside the piston cylinder arrangement. While in our petrol, diesel or the gas engine, the fire takes place inside the piston cylinder arrangement. That means the working substance is fire. Working substance is fire. So this type of the engine are known as the internal combustion engine. Again, the heat engine are two types: the external combustion engine, such as example is steam engine, and second type of the heat engine is internal combustion engine, such as the petrol, diesel, and gas engine. In external combustion engine, the fire takes place outside of the piston cylinder arrangement, or in short, the working substance is not fire. While in internal combustion engine, the fire takes place inside the piston cylinder arrangement. In short, the working substance is fire. Right? Okay. The working substance goes through the cyclic processes. It absorbs the total amount of the heat Q1 from an arrangement or the external reservoir at higher temperature T1. Again, during the working of heat engine, the working substance goes through a cyclic process. It absorbs the amount of the heat Q1 from an external reservoir. Here it absorbs the Q1 amount of the heat from external reservoir, which is kept at the higher temperature T1. And it releases the heat Q2 in cold reservoir at temperature T2. And this cold reservoir is known as the heat sink. Heat sink means that the additional heat is released in the region or the arrangement that is known as the heat sink. Again, the working substance goes through a cyclic process. It absorbs the amount of the heat Q1 from an external reservoir at temperature T1, and it releases the heat Q2 into a cold reservoir is at temperature T2. So that is the heat engine and its working and types of the heat engine. Again, what is the heat engine? Heat engine is a device by which a system undergoes a cyclic process that results the heat conversion or the conversion of the heat to the work. Now, a simple heat engine is shown in the figure. The gas enclosed in piston, enclosed in a cylinder with piston, receives the heat from the burner. On absorbing the heat, the gas is expanded and pushes the piston up. So, wheel start rotating. To continue the rotation of the wheel, an arrangement is necessary to the heat engine so that the piston moves up and down periodically. So as a result, the wheel continually, the rotation of the wheel is continuous as the piston moves up and down. Okay. The gas is called the working substance and the burner is the heat source. The heat engine are two types: external combustion engine, example is steam engine. Now internal combustion engine, example are diesel, petrol and gas engine. Okay. The working substance goes through a cyclic process. It absorbs the heat, amount of the heat Q1 from an external reservoir kept at the high temperature T1 and release the heat Q2 into the cold reservoir or the heat sink at low temperature T2. Low temperature T2. So there is the heat engine and also it's working. Now, after that, how we obtain the efficiency of a heat engine? For that purpose, the question is that there is the most important question: give the basic features of heat engine based on a cyclic process and obtain the formula of its efficiency. Again, the question is that give the basic feature of the heat engine on the basis of cyclic process and obtain the formula of its efficiency. Now, the basic features of the heat engine are that the engine absorbs the heat Q1 from the hot reservoir at temperature T1 and release the heat Q2 to a cold reservoir is at low temperature T2. And the work done by a system. And the work done by the system. Again, what is the basic feature of the heat engine on the base of the cyclic process? The basic feature of the heat engine are the engine absorbs the heat Q1 from a hot reservoir at temperature T1 and release the heat Q2 to a cold reservoir at temperature T2 and work done by the system. Because after the absorbing the heat, so gas expands as a result, the work done by the system to pushes the piston up. Now, the block diagram of working of a heat engine is shown in the figure. So there is the hot reservoir at temperature T1, there is the working substance, and there is the cold reservoir at low temperature T2. So how the heat engine is working? So whatever the gas is taken as the working substance, absorb the Q1 amount of the heat from the hot reservoir is at high temperature T1. So Q1 amount of the heat is absorbed. Out of the Q1 amount of the heat absorbed, the some part of the heat is utilized to do the work or to push the piston up. And once the piston up, now the additional heat energy is taken out to the heat sink. That means the Q2 amount of the heat is released in cold reservoir, which is at low temperature T2. Right? Q1 amount of the heat is absorbed by the working substance from the hot reservoir, which is at temperature T1. So some part of the Q1 is utilized to do the work W. And the remaining heat energy is released in a cold reservoir, which is kept at T2. That means the Q1 is equal to W plus Q2. Some part is utilized to do the work and remaining part is released as a Q2. Therefore, Q1 is equal to W plus Q2. The net amount of the heat absorbed by the working substance is Q1. And Q2 amount of the heat is released. Therefore, W is equal to Q1 minus Q2. How much work is done? So Q1 is absorbed, Q2 is released. So Q1 minus Q2, this difference gives the work done by the substance. Okay. For cyclic process, we know that the Q is equal to W, therefore work done is equal to change in the heat energy. Q1 is absorbed, out of this Q1, Q2 is released, therefore difference between the absorbed energy and released energy, that gives the work done. Therefore, total work done W is equal to Q1 minus Q2. Now, what is the equation of the efficiency? The ratio of net work done per cycle to the total amount of the heat absorbed per cycle by working substance from the hot reservoir is known as the efficiency. Efficiency of a heat engine is that the ratio of the net work done per cycle to the net heat energy, or the total amount of the heat energy absorbed by the working substance per cycle is known as the efficiency L of the engine. Therefore, efficiency is equal to net work done per cycle to the heat absorbed, total heat absorbed per cycle. How much work done? W. Therefore, efficiency N is equal to W upon Q1. But the W is equal to Q1 minus Q2. And total amount of the heat absorbed is Q1. Therefore, W upon Q1. Equation 1, W is equal to Q1 minus Q2. We substitute the value of W, Q1 minus Q2 upon Q1. So is equal to 1 minus Q2 upon Q1. That is the equation of efficiency of a heat engine. Now, from this equation 2, if the Q2 is 0, yes, we take the Q2 0. So what's happened? We obtain the efficiency is 1. That means the efficiency of the heat engine becomes the 100% if the heat released in a cold reservoir is 0. But that is not possible. Why not possible? Once the piston moves up by absorbing the heat. So how we make the piston bend to its original position? If this heat is taken out from the cylinder. So as a result, we had to release this additional heat to the cold reservoir. Therefore, Q2 never becomes 0. Therefore, we never obtain the 100% efficiency of a heat engine. Again, give the basic picture of the heat engine and give the basic picture of the heat engine on the basis of the cyclic process and obtain the formula of its efficiency. The basic feature of the heat engine are: the engine absorbs the heat Q1 from the hot reservoir at temperature T1 and release the Q2 amount of the heat to the cold reservoir at temperature T2, and work done by the system. The block diagram of working of a heat engine is shown in the figure. Now, working substance absorb the Q1 amount of the heat from the hot reservoir at temperature T1. Some part of the absorbed heat is utilized to do the work, and remaining heat energy is released in cold reservoir is at temperature T2. Therefore, the net amount of the heat absorbed by the working substance is Q is equal to W, and W is equal to Q1 minus Q2. How much net heat is required? Q1 is absorbed, Q2 is released. Therefore, Q1 minus Q2 is the net heat absorbed by the working substance. And according to the cyclic process, this heat absorbed is equal to the work done by the system. Therefore, Q is equal to W, and W is equal to Q1 minus Q2. Now, efficiency of a heat engine. The ratio of net work done per cycle to the total amount of the heat absorbed by the working substance per cycle from the source is known as efficiency of a heat engine. Therefore, efficiency is equal to net work done per cycle to the heat absorbed per cycle. Therefore, N is equal to W upon Q1. But from equation 1, W is equal to Q1 minus Q2 upon total amount of heat absorbed Q1. Therefore, 1 minus Q2 upon Q1 is the equation of efficiency of a heat engine. Now, from this equation, Q2 is equal to 0. Q2 is what? The heat energy released in cold reservoir. As we take the Q2 0, therefore N is equal to 1. It means the efficiency of a heat engine is 100%. But efficiency of a heat engine is 100% is never possible, because the Q2 never becomes 0. Clear it? Okay. So that is about the heat engine and also block diagram and its efficiency. So this question is most important for exam, right?